This steel story begins not in a mine, but in mountains of discarded metal waiting for a second life.
The first real step is sorting, because not all scrap behaves the same in the furnace.
Old vehicles are one of the largest visible sources of recyclable steel in the yard. Demolished buildings and factories return as another major stream of recyclable steel. Before shredding, crews remove anything unsafe or unsuitable for the machinery ahead. Prepared scrap is now fed continuously toward the first major reduction stage. Loose, thin scrap is compressed into dense bundles that are easier to move and process. Once sorted, the scrap begins moving from storage toward actual processing. Inside the shredder, old steel is broken down into fragments the plant can truly control. All of the preparation so far leads to this machine, the primary shredder. With the roof closed, the vessel is ready for the electric arc to begin its work.
Supplemental oxygen and burners accelerate melting and help the furnace work more efficiently.
At this point, scrap has become a furnace-ready feedstock rather than random waste. With the basket loaded, the recycling line enters its hottest and most intense stage. Magnetic systems help isolate the iron and steel from everything else riding the conveyor. The graphite electrodes are lowered into position to start melting the recycled metal. The melt shop builds each charge basket carefully to support stable furnace melting. The cleaner the incoming scrap, the more stable the melting process will be later.
The electric arc furnace is the heart of modern scrap-based steelmaking.
Before melting can begin, the furnace opens to receive its first load of scrap. Air separation removes light waste and leaves behind a more concentrated steel stream.
The upper layers begin softening and dropping as the arc cuts deeper into the charge.
Once shredded, the metal moves into a series of cleaning and separation steps. The first charge falls into the furnace, filling it with recycled steel fragments. Once the arc strikes, electrical power turns into the extreme heat needed to melt steel.
Magnetic recovery ensures that most of the ferrous metal is captured for steelmaking.
After shredding, the old cars and beams are no longer recognizable. Only steel remains. Below the remaining scrap, a molten bath begins to form from the recycled steel. Not just purity, but size consistency matters before the steel reaches the melt shop. Lime and other additions help create a slag that captures unwanted impurities. A foamy slag layer improves melting efficiency and helps clean the steel. As the first charge melts down, more scrap is added to build a full heat. The furnace continues melting until the entire charge becomes one liquid mass. At this stage, operators check chemistry and temperature to steer the melt toward the target grade. Once chemistry and temperature align, the heat is ready to leave the furnace. Some grades require vacuum treatment to remove gases and improve internal quality. Refining continues as oxygen reactions lower carbon and remove remaining impurities.
With melting complete, The heat moves to secondary refining for precise quality control. Alloy additions turn a generic melt into the exact steel grade required by the customer.
The furnace now pours its heat into a ladle for final adjustment and cleanup. Operators try to keep slag out of the ladle so the next refining stage starts clean.
The ladle furnace restores temperature and opens the door to much tighter chemical control.
Argon stirring helps blend the steel evenly and float inclusions toward the slag.
Alloy additions turn a generic melt into the exact steel grade required by the customer.
Before casting starts, the plant verifies that the steel matches its final target. The molten steel now heads to the caster, where it will become billets. After solidifying, the strand is straightened into a long, continuous billet. The tundish acts as a buffer, keeping the flow into the mold steady and controlled. Every billet is identified, so the plant can trace quality from melt to final product. Inside the mold, the outer skin solidifies first, while the core remains liquid. As it leaves the mold, the strand is solid outside and still liquid at the center. The continuous strand is cut into billets sized for the rolling mill. Before rolling, the billets are reheated so they can be shaped continuously without cracking. The billet must be evenly hot all the way through before it reaches the first stand. With casting complete, the billets move toward the rolling mill that will shape them into rod. The mill strips away hot scale before shaping begins.
This steel story begins not in a mine, but in mountains of discarded metal waiting for a second life.
The first real step is sorting, because not all scrap behaves the same in the furnace.
Old vehicles are one of the largest visible sources of recyclable steel in the yard. For straight products, the line cuts the steel into standard lengths before bundling. Tensile testing reveals how the steel behaves under real structural loading. Automation organizes the finished steel into bundles that can be handled safely and consistently. Every bar is checked to ensure the geometry matches the required reinforcing standard.
Once the tests pass, the finished bundles are cleared for delivery.
Bend testing confirms the rebar can be formed on-site without breaking.
Every bundle gets marked, so its origin and specifications stay traceable. Representative samples are tested to prove the steel meets the required grade.
The finished steel is strapped into dense bundles for storage and shipping. At the site, the steel stops being cargo and becomes building material.
Steel stands out because it can return from use to production again and again.